Hi, this is Francis from A Plus Tutoring. In this session, I'm going to show you how to do integration by parts with an example. Now, in this example, how do I know that this is integration by parts? So I will actually go back to my formula sheet, the summary for Calculus 2. Now, if I look at this table, does my example look like any one of these? X cos of 2x. So I have x cos of 2x, so that is basically this one, right? So I know that if it's anything that is on this table, I know that it's integration by parts. Or sometimes there are functions that is not on this table and is also using integration by parts. But then that will be more like exceptions, okay? So mainly, I'm going to refer to this table to use integration by parts. So the first thing that you have to think of is this table. Now I have x cos of 2x. That means I have to set my u to be my x and dv to be the rest. So how do we use integration by parts here? So I know that u is x. And now I know that dv is the rest, which is cos of 2x dx. All right, so this is, you have to do the integral of this part. Now what is du? Du is dx. And what is v? V has to be the integral of this, and I have 2x here. If you are not really used to how to do integral of cos of 2x with a number in front, you have to use a substitution here. So in this case, it's basically, so if you just do it on the side, cos of u, I wouldn't use u because that would be redundant. So let's use v. Well, v will be the same thing here. So let's use y, right? Cos of y. Okay, now dx is basically, since y is 2x, then dy must be 2dx, right? So I have a dx over 2. So this is the part that most students forget about, divided by 2. Okay, if you substitute y equals to 2x, dy must be 2dx. So that's why you have dy over 2, I would say. I don't know why I put a dx on top. It should be dy, right? Because now it's in terms of y, dy over 2 is my dx. Now, so that I have cos of y dy over 2, the integral of this is going to be, so if you go back to my formula sheet, you find out that integral of cos is going to be sine, right? So sine, so this is going to be sine, so 1/2 sine of 2x plus c. Okay, so this is my v. Now that you can apply the formula, which is uv minus integral of v du, that's basically the integration by parts formula. That's equals to, u times v is x times this. So I have x over 2 sine of 2x. Subtract integral of v, which is this part, times du. I have 1/2 sine of 2x times dx. And this is basically, I still have a plus c because I already evaluated one part of it, so I'll just add a plus c at the end. So some teacher just ask you to do that at the end step to add a plus c. So I'll just, before I forget about the plus c, so I'll just put it there. Now this integral is basically similar to what we just did here. So if I again do y equals to 2x, dy equals to 2dx, so I will have dy over 2 to be my sine. Now the integral of sine is going to give you minus cos. So in this case, I know that my answer is going to be x over 2 sine 2x minus 1/2. Okay, I take out the 1/2. Integral of sine 2x dx, which is 1/2 minus cos of 2x plus c. Okay, so this is basically my answer. Now, let me just simplify this a little bit more. This is going to give me a quarter, but then it's a plus here. Okay, so let me just rewrite my answer nicely. I have x over 2 sine of 2x plus 1/4 cos of 2x plus c. So this is my answer for this. So for more information about integration by parts, please visit my website, goforaplus.com.